Welcome to PCP Heaven Tech Labs. Today I will show you what's inside the DC motor. Now I have prepared my work model for DC motor for this reason, and as you can see this is fully functional. It can rotate either way, clockwise and counterclockwise, and on the back side you can see the bearing that holds the shaft and the shaft itself and the two poles that the motor is powered from. Now, instead of breaking the motor apart and explaining each part as I take it out, I would rather prefer to go backwards, and I will start from scratch and build the motor from the beginning. Okay, now I strip the motor and there. Nice. So, this is the basic part of the motor. This is the shaft, and on the shaft the two electromagnets are welded. Actually, these are only the cores of the electromagnets. They still lack of the coils, and the coils are actually the ones that I will start with making the motor. The coils are made of thin single core wire from copper most of the times. That it has no plastic shielding outside. Instead, it has a special paint, and this will prevent the short circuit between the windings. And there. Now, this will be the first coil of the electromagnet. The motor has actually two electromagnets, something that does not happen in the real life. But this motor is made only for educational purposes, and I try to keep it as simple as possible. So, this is our electromagnet, and now it's starting to look like a motor again, and it's time to give some power to the coils. This is the tricky part of the DC motor. So to provide the power, I need to build something that's called commutator. The commutator is actually a ring. This ring is above the electromagnets, and it's fixed on the shaft. This ring rotates along with the shaft, and the ring is made of non-conductive material. This is very important. On the perimeter of this ring, there are two other parts that they are made of conductive material. This is the first part of the commutator, and it must be able to stand friction in high revolutions. You will see later why. Now, on the other side of this ring is the other half of the commutator. Again, it's made of the same conductive material. It has the same wire to provide power to the coils, and now both electromagnets have their wire endings connected to the commutator. Now look closer to these pieces. They're actually not connected together. There is a gap between them. And on a real motor, this gap is times smaller than a millimeter. On the other side, there is the same gap. And now, let's take a look around. So, we've made the commutator piece. Now it's time to put something to hold the shaft in position while rotating. And what could be better than a set of nice ball bearings? There. The motor has actually two bearings, one above the commutator and one under the coils. The bearings are very important on the motor, and actually the bearings along with the brushes are the parts that wear off on the motor. Now enough with the bearings. Now, according to the theory of operation of these motors, the electromagnets rotate inside the magnetic field. So now we need to make a magnetic field. And this field will be made out of two permanent magnets placed one opposite the other. Now this is the first piece. This piece of permanent magnet has its north pole facing the coils of the motor. The coils will rotate in front of this magnet, and it will be actually in a very close distance, about 1 or 2 millimeters for small motors. And now we need the other half of another magnet with the other pole facing to the coils. Now this one. This magnet has the south pole facing to the coils. So between these two magnets there is a permanent magnetic field, and the coils will rotate inside this magnetic field. I will continue making my motor. The internal parts are almost ready. What I need now is a way to provide power to the coils while they rotate. Now remember that the poles of the windings of the coils are both connected to the two pieces of the commutator. Now there is another part called the brush, and this is actually why this kind of motor is called brush motors. The brush is a piece of metal that acts like spring. On one end there is a conductive material very durable with friction, like the one used for the commutator. Usually this is made out of carbon. Now the metal will push this piece on the commutator, and so it will create contact between these two. On the other end of this piece of this metal there is the power connector of the motor. This is where you connect the power actually. The current goes from the power connector through the metal spring and through the carbon connector directly to the commutator, and then it's provided in both coils. And of course there is another brush opposite this one, with the same structure of operation of course. It will give power to the other piece of the commutator. Now watch what happens while the shaft is rotating. The brushes have always the same polarity as provided by the power supply, but as the shaft rotates, the polarity driven to the coils is changed, because every time for example the left commutator goes one time to the positive and one time to the negative power supply, and this is how the electromagnets change their polarity. That's the tricky part of the DC motor. Perfect. Now it's time to put it all together, and I will put the housing of the motor. It has a proper place of course for the ball bearing, and the electromagnets are also fixed on the walls of this housing. Now that's the housing, and our motor is almost finished. It looks nice. It's time for the final part. I don't really know the name of this part. I will call it a cover. Actually it's a cover. It covers everything, and it also has a place for the bearing on top. It will hold the bearing on top, and it also has two holes for the power terminals, and the motor is ready, fully functional, everything in position. That's it, and thank you for watching this video, and don't forget to visit our website for more interesting projects.